The Institutional Water Treatment Program is a small, underfunded group doing the important work of saving water, energy, and money. We provide expert water treatment advice on heating, cooling, and other systems to over 100 state facilities. Our job is to chemically balance water used to move heat. For the average person, this happens out of sight and on a scale they probably can't imagine. For example, the air conditioning in this campus is provided by an underground loop circulating 10 million gallons of chilled water. We treat water in order to minimize corrosion, microbiological growth, and the formation of scale, or in other words, rust, bugs, and rocks. And in doing so, we save piles of money by extending service life and reducing energy costs. How much money? Typically, the investment in heating and cooling systems might be 10 to 15% of the cost of a building's construction. A rough estimate for the value of those systems on this campus might be $600 million. So any extension of service life adds up quickly. Corrosion is a primary concern. This is a filter on a system with corrosion problems. An unprotected system can corrode 10 to 20 times as fast as one with adequate protection, which is provided by good water treatment. For example, 100 feet of 12-inch steel pipe that corrodes at a rate of 5,000ths of an inch per year loses 64 pounds of metal and produces 2.6 cubic feet of rust every year. That's as much rust as a medium-sized dog. Corrosion rate has a drastic influence on service life. The ideal corrosion rate of 5/10,000ths of an inch per year gives a service life of 250 years. At 1/100th of an inch per year, that life is 10 years. Other mechanical parts of the system can also be destroyed by corrosion, as shown in this picture of a severely corroded pump impeller. So one might say, we are the only 3 guys in the state who actually get paid to make stuff not happen. Biological growth is also a major source of concern, especially in cooling tower systems, which remove heat from large buildings by evaporating water. These systems are an ideal breeding ground for all sorts of bugs. Here are some cooling towers on the ULI campus. Bacteria, algae, and fungi cause a number of serious problems in cooling and heating systems. Some bacteria eat iron, others excrete acid, which causes corrosion, while others exude a protective biofilm that greatly reduces heat transfer and efficiency.
Legionella is the bacteria that causes Legionnaire's disease, a severe pneumonia which hospitalizes up to 18,000 people a year with a 5 to 30% fatality rate. Legionella can grow in poorly treated systems of all sorts, but especially cooling towers. Improper water treatment is a public health hazard. Here's a picture of a cooling tower severely contaminated with bacteria and algae being disinfected with chlorine. The foam is the result of the high microbiological kill rate. Scale formation is another problem, especially in cooling towers, which can evaporate thousands of gallons per day. Keep in mind, here in Champaign, every 1,000 gallons of water carries 3/4 of a pound of minerals with it. So here's a picture of internal tower fill. It's not too dirty. And this is what it looks like when it all goes terribly wrong. A poorly run cooling tower is the equivalent of a limestone factory. This greatly reduces the efficiency of the cooling system and results in much higher energy usage, plus cleaning and repair costs. These are vertical boiler tubes covered with scale due to improper water treatment. As little as 1/8 of an inch of scale can reduce boiler efficiency by 25%. Scale can also cause a boiler tube to rupture. Tap water can have scaling issues also. Calcium has the unusual property of becoming less soluble as the temperature rises. The severe scaling in this hot water pipe has rendered it unusable. This results in the costly reinstallation of new pipe. Some IWTP statistics. Each year we travel over 30,000 miles. We make 350 site visits to over 100 facilities. We analyze 2,500 field samples and do a full laboratory workup on at least another 100. So how do we save piles of money? By maintaining clean and efficient heat transfer surfaces, by extending the service life of equipment, by reducing the labor associated with cleaning, repairing, and maintaining the system. We also save money and reduce environmental impact by reducing chemical use and thus chemical discharge into the environment, by reducing all forms of energy input into the system, coal, gas, or electricity. A well-run water treatment program has one of the highest returns on investment of any capital expenditure. Estimated savings from our program are $2 to $10 million every year. Not bad for 3 people with 2 part-time helpers and a budget slightly over 10% of our lowest estimated savings. Thank you.